Hello everybody! My name is Neha and I'm a member of the Teen Advisory Board here at Howard County Library System. And today this will be the second video in my Stoichiometry series. If you are looking to get a basic understanding or just the overall gist of Stoichiometry, I highly encourage you to check out my previous video. But for this video, let's dive right in. So, this problem reads, how many liters of carbon monoxide form at the same time 0.246 moles of CS2 form? So, let's break this problem down. In this problem, we are actually given a chemical equation. Would you look at that? And we know that we are also given in our problem 0.246 moles of CS2. And we want to figure out how many liters of carbon monoxide are going to form. Well, we have identified what we are given and what we want. So let's write down what we are given. And that is the 0.246 moles of CS2. And we are just going to put it over 1 just for organizational purposes. And now, the next step is going to be to determine what our next conversion factor is. And the easiest way I like to think about it is to make sure that our units are going to match up. We see in the numerator we have moles of CS2, so we know in the denominator of our next conversion factor, we're also going to have the unit of moles of CS2. And now it's just a matter of figuring out what numerical value we put. And the answer to that is just going to be 1 because we are not given any abstract value. We just want to be able to convert between these units. So now the next step we have is to determine what our numerator is going to have. And that is going to be moles of carbon monoxide. So let's think about this. We are given moles of CS2, and we want liters of carbon monoxide. Well, we can't just automatically skip from moles of one value to moles of a totally different substance. We have to be able to convert from moles of CS2 to moles of carbon monoxide, and then finally be able to convert to liters of carbon monoxide. So that is why we're not jumping right into liters. We are jumping to convert from moles of one value to moles of another value. And how do we get 4? Well, that's fairly simple. We get 4 right from our chemical equation. Okay? So, now that we know we are at moles of carbon monoxide, but we want liters. So we have to determine another conversion factor. Well, we know what we're going to put in our denominator because we have to make sure our units cancel out. So that's just going to be moles of carbon monoxide. And why 1, you ask? Well, simply because we're not going to convert anything abstract. We just need a placeholder. And now we can convert to our liters. So, where are we getting 22.4 liters from? Well, just like we talked about in our previous video, 22.4 is a universal value we use all throughout chemistry. And it's one of those values that you should memorize, that you should have in the back of your mind. Because this is universal, you're going to use it all the time. Well, now that we have reached liters of carbon monoxide, we've reached what the problem is asking us for, right? So that's it. We can just make sure that our units cancel out real quick. So we have moles of CS2 and moles of CS2. So those are going to cancel out. We're good there. And we have moles of carbon monoxide and moles of carbon monoxide. So we're good there too. So we can go ahead and multiply. And when we multiply, we get 22 liters of carbon monoxide. So, all stoichiometry problems are basically just an understanding of setting up appropriate conversion factors. So now let's move on to the next video. this problem says, what mass of potassium hydroxide is required to react completely with 2.7 grams of sulfuric acid to produce potassium sulfate and water? That was a mouthful. Let's break it down. Whenever we have these problems, it's important to understand what the problem is asking. And basically, the problem is simply what the chemical equation gives us, but in words. So it's asking us what mass of potassium hydroxide is required. So that's what we want. And we know that we are given 2.7 grams of sulfuric acid. So we know that that's what we are given. So we can put that down. And just for organization purposes, I like to put it over 1. So now we have to find a conversion factor. Well, we know that if we have grams of sulfuric acid up there, we also need to have grams of sulfuric acid in the denominator. And we need to be able to figure out how we get our molar mass of the sulfuric acid. And that is going to be based on the periodic table. So we know hydrogen approximately has a molar mass of 1, and we're going to multiply it by 2 to get 2 grams. We know that sulfur has a molar mass of 32 grams, oxygen has a molar mass of 16 grams, but since we have 4 of those oxygen, we're going to multiply by 4 to get 64 grams. And we are going to add all those values together to get 98 grams per mole. So that is going to be our molar mass. Now that we've set up our denominator, we have to figure out what we want in our numerator. Well, we have grams of the sulfuric acid, and we want the mass, so the grams of another substance. So that means we're going to have to start to set up a conversion factor. And in the numerator right here, we put 1 mole of the sulfuric acid because that will set us up to be able to convert to another molecule or substance or whatever, depending on the problem. So now we know that in our denominator, in order to make sure that our units match, we have to make sure that we're going to put the same unit here. So we have moles of sulfuric acid up there, so we're going to put moles of sulfuric acid in our denominator. And in our numerator, this is going to be our big conversion factor to convert it to potassium hydroxide. And we know we're going to put 2 moles of this potassium hydroxide because that is what is given in our chemical equation. So now we have reached the moles of potassium hydroxide, but we want the grams, we want the mass. So we're going to do one more step and figure out what our grams value is. So in our denominator, we're going to put moles of potassium hydroxide because that is what is going to allow us to cancel out our units. And in order to be able to find the grams value, we're going to have to do the steps once again to find the molar mass. So potassium has approximately a molar mass of 39.1 grams, oxygen has 16, hydrogen has approximately 1, so we have our total molar mass to be 56.1 grams per mole for potassium hydroxide. And that is the value that we're going to put in our numerator. Finally, we have reached the unit we want, the unit our problem is asking us for. So we can make sure that all of our units cancel out, and if we multiply all of that together, we get a final answer of 3.01 grams of KOH. So do you see how all of these conversion factors play out and contribute to this problem? This is a big component in all of these stoichiometry problems, and it's important for you to understand. Well, thank you so much for watching, and I'll see you in my final video on the stoichiometry series. Thank you!